Hello guys, my name is Arun and welcome to my channel. This series is a series of tutorials on Fortran programming. Now in the last tutorial we were working on this program wherein we were trying to calculate, we were trying to find a sliced matrix and a slice of a matrix using the mask feature available and reshape and pack features available. At the same time, we also looked at how to print the matrix in the standard matrix kind of format, the arrays in the standard matrix kind of format, and we also looked at the column based memory allocation features of Fortran. Now in this tutorial, this will be an extension of this, since some features that we learned over here, especially the write with advanced no feature, the reshape, pack and slicing, okay, we'll be using this in our program. In this tutorial we'll be looking to find the determinant of a program, determinant of a matrix, using the features that we learned before, and this will include the usage of subroutines and functions. Now what I have here is I have a program called as deter. It goes from here and ends here, and then I have a recursive function, real function, and then a subroutine. Okay, I'll explain you guys how this works as we go along. Okay, now if you guys must be knowing, determinant of a matrix is actually the product of the first element of each row, something of that, sum of the product of the first element of each row times the matrix, the matrix which does not have the row and the column of that element, and going on. I know that's kind of a lame way to look at, I think, but you guys will understand and we go along. To write that, what I've done is that I have made an implicit none statement, and then I defined a parameter n which equals 3. Now what this will do, it will set the shape and size of the matrix accordingly. Shape of the matrix accordingly. Now with this being constant, it kind of like statically allocates the memory for the matrix. Okay, and now this is the matrix for which the determinant has to be found, and its dimension, it's a real matrix of type of kind 8, and it's a size n comma n. Since n is 3 here, it's 3 comma 3 here. Now if you just want to change it, we can just change. If you want to change the value of n, just change the value here and that will be done. And then what I'm defining here, I'm defining a real variable of kind 8, and it's external. Now since this is external, now this will be nothing but a function. Now this is a function that we'll be using, detf, and then detf, and then I'm defining a value det of kind 8 and real number. This is the determinant. I'm defining two integers I comma j. Now what I did is that just like using the same program, same function methodology that we adopted here, I'm defining 5 matrices, 5 different values of matrix. Okay, one of them will have this value, other will have this value, like that and all. I just commented that out. I also written the different determinant values of these matrices. Okay, as of now I'm allocating this value to the matrix at. Okay, and now this is where I'm calling the external function detf to find the determinant. Now this function will return the determinant, and it'll have as a parameters, it will have two values, namely the det and namely the matrix and the order n. Okay, and now this will do all the calculation, and this is just a printing statement that we kind of used here. Okay, I'm just going to print the matrix in a proper matrix like format over here. Okay, this line will print each and every value of the row, and then this will help you, this will just give a new line break so that the other row of the matrix can be written accordingly. And then I'm printing the determinant here. Now let's look at the real function here. Let's look at this real function which returns the returns the determinant. Okay, for this I'm defining this to be a recursive function. Okay, Now this function is recursive and it is of type 8, okay, and this is a determinant, this is the function definition. This is the function named detf, and it takes two arguments, a matrix of name n mat and its size n, okay, and this will give us a result det. I'm writing this separately because this is recursive and I don't want to make it I don't want to make it same value confusing. So I'm going to set the result value as det. Okay, inside what we have is that I have an implicit none statement. I'm getting the value of n inside, and this will be defined as an integer and its intent in, so that this value is coming inside the function and it will not change throughout the operation of the function. Okay, and now similarly using this value of n, I define the matrix mat that will coming in, and just like on the top, this is of real 8 and its dimension n comma n that I'm setting here. I'm just adding one more attribute called as intent in, so that this matrix again remains untampered. Okay, and then I'm defining a new matrix here which is for the calculation purposes. Okay, this is of type 8 real, and this dimensions are for these are like one row and one column less than this given matrix, and this is nothing but the sliced matrix that we'll be going to use. All right, now I'm setting this initial. I'm here. I just wanted a variable. I just want an integer variable I, so I'm setting I here. Okay, and now initially to start the calculation, I'm setting the determinant value to be 0. All right, and determinant value to be 0, and if now this is the loop that does all the job. Now if the determinant of the matrix, if the order of the matrix is 2, then the determinant will be the product of the diagonal elements in a 2,2 matrix. The determinant will be the product of these diagonal elements subtracted by the product of the anti-diagonal elements. So this will be a simple case. And okay, I forgot to add one more statement. Else, suppose if somebody enters a one-dimensional matrix, let's say, then the determinant will be equal to mat 1, 1. That's it, and that is it. And I'm using return value here. Okay, I'm using a return value here, so that what this happens is that this arithmetic will be calculated and it will be stored in this value, and as and when this value is calculated, it will just end the function and return this value whenever it is called. Now suppose somebody enters a matrix of size n which will not fit in this category. All I have to do is that I have to use this function. Alright, all I have to do is that use this else if, and that will take care of it. Okay, and now we'll be experimenting with these two, and then finally, now if somebody enters a matrix of size 3 or greater than 3, then we need an arithmetic to do that. So now that will be taken care of in this else statement. What it will do is that it starts a do loop from I value 1 to n, and every time it calls a subroutine called as slice f, and it will take the value sl, mat, n, and 1 and I. Okay, now the determinant, I'll explain the function how this works. Okay, now this line, the determinant will be equal to the previous sum it had plus minus 1 power minus 1 raised to the sum of the row index and the column index. I is nothing but the column index here. Okay, I'm expanding the determinant using the first row. You can expand the determinant using any row of your choice, but I'm using the first row here, so that doesn't matter. I'm using the first row, so expand first row, sum of the index of the first row and column here, and then this power times the matrix value at the first row and the index I and the ith column, ith column, product, and that is multiplied by the determinant of the matrix which does not have this the index I, the first row and the corresponding column in consideration. Okay, now if you guys look at the determinant, when you are trying to expand it, all you need is the cofactor matrix. Now that cofactor matrix is given now I think it's a minor, because this -1 power times takes care of the cofactor issue. So this matrix will actually return the minor of the matrix for that given index. This, suppose if your row is 1 under consideration, a column is 1, okay, this matrix will just remove the first row and the first column of that matrix and will return the remaining portion in the form of SL, and that will be passed in for finding the determinant, and this function will call itself again and will proceed further. Okay, and now it will recursively call until it hits one of these two statements, and then comes out, and similarly this looping will continue. And to do this slice f, okay, to get the value SL, I'm calling a subroutine called as slice f. Now this slice f is nothing but the implementation of this slicing operation we done here in a simplified manner. This is it. What I've done is that I've written a short subroutine called as slice f. It'll have the 5 parameters arguments passed into it. I have an implicit none, and I have 3 integers whose values I'm taking in. Okay, those values are n, the order of the matrix, the row that has to be sliced out, and the column that has to be sliced out. And then I have a real matrix of size n, real square matrix of size n, okay, of type 8, of kind 8, and I'm getting the value inside that is mat. Okay, that is mat. And then what I'm going to do is that I'm going to define a matrix SL. I'm going to define this matrix SL, whose size will be 1 row and 1 column less than this matrix, and I'm defining this matrix with the parameter intent out, meaning this value will be the output value that will be going out, meaning it will not come with any predefined value. So this subroutine will alter the value of this function, this variable, and that will be going out. And then, just like in the previous program, I defined a logical matrix of dimension n, n. I named it mask. Okay, now I set all the value of mask to be true, and then just like this statement over here, I'm setting the row to be false and the corresponding column that has to be masked to be false. And now, just like using this operation over here, okay, I am I'm just masking all the values that are not available as per this, and using the pack function, and using this shape operation, I am shaping this matrix to the required shape, to the required one, and therefore I'm getting a sliced matrix out, and this matrix will be used here. Alright, now if you guys did not understand this, I recommend you guys just watch this video again, and parallelly, while you guys do this, take a piece of paper and I recommend you take a piece of paper and work this out, or think little carefully. You'll get the logic nicely. Okay, actually I thought of coding this and explaining this simultaneously, but this code took me some time to do, and when I recorded it just took a lot of time. Okay, so I thought of writing this and explaining guys how this works. Okay, now this being said, all I have to do is just compile, build, and execute this. There you have it. This is the matrix. Okay, I keep it here. Okay, this is the matrix here as of now, and it printed out the matrix nicely, and the determinant is 1. Okay, Now let's change the determinant. Okay, now let's change the matrix. Now let me put this here. I'll compile, build and execute this. Yeah, perfect. For this matrix, okay, the determinant is minus 306 and it printed out minus 306 very nicely. Okay, similarly let's take another matrix, this matrix. Okay, this is by far a singular matrix, meaning it does not have determinant. If I were to run this, there you have it, the determinant is 0. Similarly, if you guys want, you can you can activate any other matrix and do it. It will work out the same. And by the way, I defined this for a 3 cross 3 matrix. Suppose if you guys want a 2 cross 2 matrix, even then it will work. All you have to do is just change the value here and add for some facility here to enter the value of the matrices, and you're done. You're good to go. And then let's check this out. Okay, now if I were to comment all this, okay, now what I do is that instead of this else if, I just write this as if. I think this should work fine. This should work fine. Okay, let me add one of these matrices into picture. This should give minus 306. Okay, yeah, perfect. It is giving 306 minus 306. So what you can do is that even this is not necessary. This is not necessary because of the slicing algorithm slicing for subroutine you're done here. This will work just fine. This will work just fine. All right. Now that's all I have for you guys in this tutorial. Hope you guys understood how this works, and this is a really nice programming experience for me. Hope you guys had some interesting thing to do here also. Hope you guys found something interesting in this tutorial. Okay, thank you guys for watching. The next tutorial we'll be looking at another way. We'll be using this determinant and this subroutine, this determinant function and this subroutine function to and we'll be using this for another application which will be very much useful, and this will make a lot of sense. In a longer purpose. Okay, thank you guys for watching. See you guys next tutorial, and bye.